Right, so this video is going to talk us through how in physics we've got these things called Newton's equations of motion. You can see I've already sort of written them up there, and we're going to look at how you can use them in certain circumstances. Now, there's a couple of important things to digest here before we sort of get stuck into some questions around the equations of motion. Firstly, you'll notice in red I've just written a very quick reminder of the key concepts that we've looked at so far. So firstly, we've got A, which is representing acceleration. We've got T representing time. U and V are the initial and final speed or velocity. Remember, we said it sort of follows the alphabet. We also said that U can be represented by V0. However, in this scenario, it's represented by U. S is our displacement or distance. Again, depends on what sort of information is in the question. Now, the equations of motion are here. There are 4 of them, and I've already written them out for us so we can see what they are. Firstly, we've got V equals U plus AT. We've got S equals UT plus a half AT squared. V squared equals U squared plus 2AS. And we've got S equals VT. You might see these equations in other forms at certain times, but it doesn't really matter how they're represented as long as you know how to use them. What's important to recognize is that 3 of these equations are quite separate to the 4th one. And firstly, I should probably say that there are ways you can derive these equations, but this video is more or less just going to look at what you can do with them rather than how you derive them. Now, the reason that these 3 equations are quite separate to the 4th one is because all of them involve an acceleration, and you can see that because the letter A is in each of those equations. Now, what that tells me is that in these questions, we have a changing velocity. And the reason I can tell that is because we have an acceleration. Without an acceleration, we would have to assume that the velocity is not changing. If you look at this 4th equation here, you'll see it just has V and it doesn't have A. And that tells me there's only 2 scenarios that this can fit. One is that we are dealing with a constant speed or velocity. And the second is that we are dealing with an average speed or velocity. It doesn't take into consideration any other scenario really, because any other one would involve an acceleration, and that's why these 3 are predominantly the ones we're going to focus on. So realistically, the main thing we're looking to do through this part of what you're learning is apply these equations into scenarios and actually allow us to get answers for questions that we might not have been able to otherwise. The key thing I've written on the side here, though, is that these equations are not taking into consideration air resistance, so we're assuming, that it is negligible. So we're just going to dive straight into some questions to see how that would work. So the first question I've got as an example here is we've got an object that is going to start at rest. It is then going to accelerate at, let's say, 6 meters per second, and it's going to do so until it reaches, let's say, 12 meters per second. The question is going to be, how long does this take to happen? Now, when you're answering these types of questions, I've got a very clear process that I would always be looking to follow, and that's that. Start off by reading the question and writing out what you know and what you don't know, and then very importantly, pick an equation and think about how you are going to solve it. So the first line here says that the object is starting at rest. What that tells me is that the initial velocity, u, is 0. It then says here that it's going to accelerate at 6 meters per second, and that tells me that the acceleration A is 6. And it says here until it reaches the speed of, well, it doesn't say speed, but it says until it reaches 12. So we're going to assume that V is equal to 12. The question here then says, how long does it take for this to happen? It's probably a little bit ambiguous. It could be talking about distance or time, but I think we'd probably assume that it's talking about time, and that's what I'm going to solve it for. But normally questions should probably be a bit better worded than that, really, but we're going to roll with it. Then what we're going to do is look at the ones that we've got and what we're interested in. We have U, A, and V, and we're trying to find T. If I look at the equations here, you'll notice that this equation here, the second one that I've listed, has S, so too does this one, so too does the 4th one. So the main equation we would choose is this one here, which is V equals U plus AT. Then what I want to do is consider what it is I'm actually trying to find, and I'm trying to find T. So as a result of that, I would need to rearrange this equation for T, and I can do that by rewriting it as T equals V take U over A. And hopefully you're fairly familiar with how I rearrange equations, but T is being multiplied by A, it's also being added by U, so the opposite of adding U is to take U, and the opposite of timesing by A is to divide by A. We then substitute the numbers in, V, as we've got over here, is represented by 12, U is 0, and A is 6. 12 divided by 6 is 2. So what we're saying is that it would take 2 seconds for that process to occur. So you can see how we've taken a problem and we've used an equation of motion, one of the equations, to then solve it. We're now going to look at a second example. So in this example, I'm going to have an object which is currently moving at 14 meters per second. It's going to slow to a stop. And I'm going to say that in this time, the object moved, let's say 22 meters. And my question is going to be, whoa, what has happened there? I should have a question about that. My question is, what is the acceleration? Okay, so there's a little bit to unpack in this question. Let's go through it. So as I said, again, the first thing I'd always be looking to do is write down what I know and what I don't know. It says it's moving at 14 meters per second. So that is the initial velocity. U is 14. I'm not sure why that's in black and not in red, but we're just going to roll on. We're going to slow to a stop. What that tells me is that the final velocity is 0. Jeez, it's getting more chaotic by the second, but we're just going to push on. And then the other thing I can sort of read here is that it has done that in a time where it's moved 22 meters. So S is equal to 22. And the question is saying, what is the acceleration, which is A? Yes, there we go. Wow, it's on a bit of a delay there. So U is 14, V is 0, S is 22, and I want to find A. Now, if I scroll up and look at the equations, you'll notice that it's going to be the second equation here, V squared equals U squared plus 2AS, which is the most relevant. We'll pick that one and go from there. So if I start with the equation, I've got V squared equals U squared plus 2AS. Now I'm trying to find A, and at the moment it's not kind of in the form that I want it. So I need to rearrange it, and when I do that, I'm going to get A equals V squared take U squared over 2S. And that's because 2AS is being added by U squared, so the opposite is to take U squared, and A is being multiplied by 2S, so therefore we will divide by 2S, and that's why it's appearing on the bottom. V squared is 0 squared, U squared is 14 squared, and 2 times S is 2 times 22. That's going to give me negative 196 divided by 44, which gives me negative 4.45 meters per second per second. So that's my answer for the acceleration. And if you're sitting there wondering, well, why is it a negative answer? The reason is because what it is actually representing is a deceleration. And the reason it's a deceleration is because this object, we were told in the question, is slowing. And what that means is that it is decelerating. So we can have an acceleration, which kind of implies that the values are getting larger or becoming more positive, for example, or a deceleration, which means that they are slowing down. So that's the value of our deceleration. The third question I'm going to sort of throw out just to finish off is we've got an object which is moving at 7 meters per second. What's going to happen to it? It's going to get, and it gets to 18 meters per second in 4 seconds. And the question I'm going to write is, how far did it go in the 4 seconds? Alrighty, same deal. What we need to do is we need to look at the question and we need to say, well, what info have I got? Starts at 7 meters per second, so that means that U is 7. It gets to 18, which means that V is 18, and it does it in a time frame of 4 seconds. And the question is saying how far, which means we're being asked to find S. You'll notice that there is no information there about acceleration. Now, if I just rewrite the equations over here just so we can see them, we're only going to be dealing with the first three, and that's because it's not a constant velocity. So V squared equals U squared plus 2AS. Hopefully what you could notice with all three of those equations is that they all involve acceleration. And what that tells me straight away is I literally cannot find S without finding A. So that's actually the first thing that I need to do. Now, if I choose the first equation there, I've got V equals U plus AT. And if I rearrange that for A, I'd get V take U over T. So 18 subtracted 7 divided by 4 is 11 over 4. 11 divided by 4 is going to give me 2.75 meters per second per second. So that is my acceleration, and that is very, very important because now we've actually got all the information we need. And what that means is that in theory, I could choose to use this equation, the second one, or the third one to find S. And it's just a matter of which one you would like to. I'm going to choose the third one just to show how to rearrange that one, but you could definitely solve it using the second one. Let's see if I can get this color to change here. Wow, there we go. So we've got v squared equals u squared plus 2as. If I rearrange that for s, I get v squared take u squared over 2a. That's because we're adding u squared, so we subtract it, and we're timesing by 2a, so we divide by it. If I throw the numbers in, I get 18 squared takes 7 squared over 2 times 2.75, and all of that is going to come to 50 meters, and that is the answer to the question of how far it went. So hopefully in this video you can see that there are the equations of motion, which are really, really interesting, and we saw that we could find some solutions to some one-dimensional problems that are involving horizontal motion.